Let's look at a series of ice-breaking questions. So the first one, indifference curves in the same graph cannot intersect with each other. The answer to this is true. That is because indifference curve, as we say, we should make analogy to contours. And for contours, they shouldn't intersect with each other because the intersection point will qualify for two different contour curves. And then that will mean this point is associated with two different elevations, which shouldn't make sense in reality. And here, indifference curve functions similarly to contours in demonstrating how high, how happy the consumers are. So then if two indifference curves intersect, it also violates, it also contradicts because then the intersection point is associated to two different levels of satisfaction. That violates at least the completeness assumption. Question 2, the closer the indifference curve is to the point of origin, the higher utility it represents. The answer to this is false. The further away from the point of origin, the higher utility it represents. Okay. Now the third one, indifference curve is always linear, namely appear in the form of lines. The answer is wrong because indifference curve only appears linear when perfectly linear when it is for perfect substitutes. For perfect complements, it's L shape, right? Two sectors, each sector is linear for each indifference curve. But normally, indifference curve appears in the form of this, a convex curve. And I'm going to explain to you this later. Okay. The fourth one, if a point is above an indifference curve, namely, which is representing U1 of utility of U1, the bundle of goods it corresponds to will yield a higher utility than U1. The answer to this is true. Okay. So basically the location matters. The further away from the point of origin above the curve, if a bundle is above the curve, the bundle represents a higher utility than that curve. If a bundle is lower than this curve or below this curve, then this bundle associated to a lower utility than represented by the curve. So here I would like to refer to you some learning material which is the summary. Let's look at knowledge points that I update after each class. Okay. Since here we've been touching upon a bunch of concepts. Okay. So I do mindfully give you the summary. Like here's same utility on all bundles of one. It is same utility on all bundles, namely all points of one indifference curve. Indifference curves do not cross with each other or intersect with each other. The farther the curve locates from the point of origin, the higher the utility it represents. And if a point locates below the indifference curve, the bundle of this point will yield less utility than that of the indifference curve. So I've got all those summarized, and I strongly suggest after reviewing the slides, go check the information here to make sure that you catch all the gists of that class. So it's in the top of the module. Okay, I do update this after each class. And now let's look at question 5. which is more challenging question. Let's look at this. What assumption of consumer preference does the following indifference curve directly violate? And here are those three assumptions: completeness, transitivity, more is better than less. Which one is violated? Okay, the answer is C, more is better than less. Because here, if you take 2 points, the first one closer to the point of origin, the second one farther from the point of origin, and because these 2 points are located towards the northeast, right? The one that is farther out should be preferable to the bundle that is closer to the point of origin, because the one that is further out is corresponding to both higher in clothes and higher in food. Then according to more is better than less, the second bundle should be preferable to the first one. But here, if an indifference curve is drawn this way, it is to say these 2 bundles should be indifferent, viewed as indifferent by the consumer. That is contradicting, right? So point C is violated. Now let's talk about the slope of indifference curve, which is defined as marginal rate of substitution. So the magnitude of the slope of an indifference curve measures the consumer's marginal rate of substitution between 2 goods, okay? And it is noted this way: marginal rate of substitution is change in quantity of clothing over change in quantity of food, and here we add a minus sign. So first question, is marginal rate of substitution positive or negative? The answer is marginal rate of substitution is positive, even though there is a negative sign here. Okay, so first let's look at delta C over delta F. What's the meaning of it? Delta C stands for the quantity. So C is the vertical axis, F is the horizontal axis. And delta C over delta F, so this is something that we have learned in the elasticity part, right? This quotient of deltas means its slope. So delta C over delta F, that is a negative slope because it's going down this way. If you can see my cursor, right? If you are confused, think about a demand function, a demand curve or demand line that is also going from northwest to southeast, this direction. So this direction is associated with a negative slope. The slope, which is delta C over delta F, is negative, and here we add a negative ahead of it to turn this into positive. And a less confusing way of putting it would be, let me add it here. Would be the absolute value of the slope. That would make it a more reasonable and possibly confusion-proof illustration. So we are actually looking into the absolute value of the slope. Okay, so then the question, another question to follow up is, why is this slope negative? Right? Why is this a -6 for additional 1, -4 units of clothing for additional 1 unit of food, -2 unit of clothing for additional 1 unit of food, -1 unit of clothing for additional 1 unit of food? Well, let's look at the definition of marginal rate of substitution. So here, if you think about this different signs between the changing clothes and changing food has already demonstrated to you a relationship of substitution between these two goods, right? So we are foregoing 6 units here from A to B. We are foregoing 6 units of clothing for the increment of 1 unit of food, right? From D to E, we're foregoing 2 units of clothing for 1 unit of food. So it's a concept of substitution. That's why its name is called rate of substitution. And here it is a rate, right? And then why it is a marginal rate? Well, it is 6 units for additional unit of food, 4 units of clothing for additional 1 unit of food, 2 units of clothing for additional 1 unit of food, 1 unit of clothing for additional 1 unit of food. Again, it is the marginal concept. Marginal means additional 1. So here it is to look into how many clothing we are willing to forego for additional 1 unit of food. Okay, and what is the relationship between all those bundles, A, B, C, D, E? Well, it is a maximum amount of a good that a consumer is willing to give up in order to obtain the additional unit of another good. So here the key language is willing to, right? So from A to B, as you see, A and B and D and E and C, they are all the same indifference curve, meaning the travel between all those dots, namely the shifts between all those bundles, will yield the same satisfaction, namely utility, to the consumer. Okay, so here then the question is, in order to make this consumer equally satisfied, what kind of adjustment between clothing and food this consumer is willing to accept or reshuffle, if you will, right? So that's the definition. That's how we understand marginal rate of substitution. But in nature, it is a concept of slope. That's why I call this the concept, the slope concept of the indifference curve. Okay, and then previously we did have this question 3, indifference curve is always linear, and the answer is no. And we say the more common demonstration or common cases of indifference curve is that the indifference curve should have this curvature. And as we learned before, this is part of the convex shape. And here is the reason why. Okay, we have one jargon for this, which is called diminishing marginal utility or diminishing marginal return in general. And here specifically to the scenario of consumers, the return from consuming a product is the satisfaction, namely utility. That's why we call it diminishing marginal utility. So this is a principle that as more of a good is consumed, the consumption of additional amounts will yield smaller additions to utility. This definition is pretty dry, and let me explain this in daily language. So diminishing means decreasing marginal utility, and here marginal utility means additional satisfaction obtained from consuming 1 additional unit of good. So let's look at this. Sometimes we observe those big eater challenge, right? Or like if you go to buffet, right? Before going to buffet, if you do want to get the money back by your consumption, possibly you may make yourself starving by skipping several meals before going there, right? So then when you are extremely starving, look at this huge hamburger. The first bite will give you a lot of satisfaction. That is the concept of marginal utility. And that one, when your consumption was low, when you haven't had anything yet, that additional satisfaction is significant. But say you keep eating down, and you are getting fuller in your stomach, and eventually the additional bite, say it's still the same size of mouth that you take in, and the same size of bite that you take in, that additional bite, say if you're now at the bottom, that additional bite, if not making you sick, right, will only yield very small increment in satisfaction for you, right? So that's what we mean by diminishing marginal utility. So your marginal utility, your utility from each additional bite is actually decreasing as you keep on biting. keep on eating, right? So this is a common rule because we people, we have a tendency to be fatigued, be tired, be fed up with something as we keep repeating this pattern repeating this pattern continuously or non-stop, right? Like here, you keep eating down, and eventually each bite will give you less and less utility. Or as you are studying for the class, right? The first hour could be very efficient. The second hour could be as efficient, and say the fifth hour would be less efficient, because if you keep sitting on there, eventually your attention span will be used up and you're going to be fatigued in your brain, right? So as long as we have a tendency like this, we will have a convex shape in our indifference curve. Here is the reason why. So we need to look at both ends. So the first end is from A to B, the second one is from E to G. So from A to B, since we know the marginal utility, right, diminishing marginal utility, has something to do with where you are in your consumption. Is this your first bite or is this your 20th bite, right? Then it is important for us to look at this point, bundle A, to examine where your consumption is with regard to clothing, with regard to food. So here, in terms of clothing, we've got a lot. Think about this in your intuition, right? You've got a closet or wardrobe filled up with clothing. It's about to explode. And possibly your roommate give you a suggestion, hey, if you don't want them, you can bring them to Salvation Army, get them donated so that you can, relax some more room for yourself. That's one thing. Right? So here, since we have already had a lot of clothing, then each additional unit of clothing does not, excuse me, does not yield a lot of additional satisfaction. Then reducing each additional unit of clothing will not affect us too much in our satisfaction, right? But on the other hand, we are very short in food. It's like the first bite, the second one, right? So at that time, a little bit more food will give us a lot of utility, increment in utility, right? Then we are willing to forego a lot of clothing, since each unit of clothing forgone will not impair your satisfaction a lot. Then it takes a lot of clothing to be forgone to compensate for the increment, to offset the increment of utility coming from this additional unit of food, because we are low in food. That's why at the beginning, from A to B, we are willing to forgo a lot of clothing that we are already excessive of, right, for one additional bite of food that we are short for. But eventually, when you're at E and G, now after taking on the process, the mission to get rid of clothing, eventually we are not rich in clothing anymore. It's only four units of clothing, but we've already had 4 units of for hamburgers, right? Then at this moment, additional 1 unit of hamburger doesn't give you a lot of satisfaction in your, not a lot of increment in your satisfaction, but when you don't have a lot of clothes already, reducing 1 unit of clothes, that means a lot to you. That will impair your satisfaction a lot, right? Then we will not be as squandering of clothing at point A when we are at point E to travel to G, right? So now we are only willing to exchange for 1 additional unit of food with the sacrifice of 1 unit of clothing. So you see, here there are 2 concepts involved. One is when we are traveling down from A to to G, right? As our consumption of clothing, as our possession of clothing keeps decreasing, well, each unit of clothing then means more and more to us in our satisfaction. As we're moving from A to G, as we're considering the food aspect, namely we're moving rightwards along the horizontal axis, we have consumed more and more food, and then each additional unit of bite will give us less and less increment in our satisfaction. And these two things combined eventually leads to the exchange rate, marginal rate of substitution between clothing and food being more and more decreasing as we are moving from A to G. So this is the first concept of today's class, which is why to better understand the meaning of marginal rate of substitution as the slope of each point of this indifference curve, and understand normally indifference curve is subject to a decreasing slope in its absolute value, or decreasing marginal rate of substitution, which is corresponding to a convex shape of its curve. So that's the first part of today's class.